Oh my gosh, guys, this literally took forever, but about a week ago, I made this schematic design. Now, it does several things. It has two built-in thorium bores. It features two phase synthesizers, which collectively are heated up to 700%. Has a silicon arc, and it uses all of the resources it's producing to upgrade a T2 units to a T3 unit. Now, there's a lot of problems with the design, mainly the amount of sand it uses, how big it is, the sheer carbide use. Each one of these is 30, and each one of these is 90, so it adds up quick. And if you just don't need that much phase, and this is definitely overkill. So I wanted to make a smaller design. Now, this is the design I came up with after messing around for maybe 15 or 20 minutes. And as you can see, it's significantly better. This phase is at 200%, just enough ozone use for one electrolyzer. It only uses 2 phase heaters, and it produces enough of everything for a primary fabricator. There's a couple of problems with this. The biggest one is I didn't like the inefficient use of space over here, so I wanted to see if I can make it even smaller, which took me down the rabbit hole of iterative designs. Now, the first thing I tried to do, I tried swapping the silicon arc and the electrolyzer, which, as you can see, it works pretty well, because all of this is significantly smaller. However, there is a pretty major problem, and that everything gets powered except for the silicon arc. There's no way to power it without going outside of the schematic, which you could argue isn't that big of a deal, but I mean, if I had it this small, I want to keep it that small. So one of the things I tried doing is I tried shifting everything up one and adding a power node here and a power node here, and that would have worked, except for the fact that the silicon was going to go into this line right here and clog the phase synthesizer, so that wasn't going to work. So after messing around for literally forever, trying to swap the direction of the electrolyzer, swapping everything around, I even ended up trying to swap where the phase synthesizer was in the nitrogen line. Literally nothing worked. I was scratching my head at this for 2 hours, and I finally almost gave up when I started messing around with the design of having this up one. And what that did is let me have the electric heater here, so I could have a power connection from the silicon arc to the electric heater. But when I realized I don't have to have the sand input here, I can actually have it down here, which gives me the idea of adding an unloader and adding the sand up here. But just with a little bit of rearranging, this is the final product. There was supposed to be a large plasma bore, so that's just a placeholder. But this is it, and this took forever. I was literally on the verge of giving up. I spent 2 hours just honestly questioning if this is even possible, what I'm trying to do is even possible, and I finally hit the right combination, and it worked. There were so many different combinations that if one thing was different about how the game worked, it would have worked, but I just kept running into a wall. Now, this design specifically is great because it has very low resource use, and you're not wasting any time while you're building it. If you're in a competitive PvP game, you're not wasting any time constructing this because it has a built-in primary fabricator. So while you're building your eco, you're simultaneously building your army as well. And what's really crazy about this schematic is that it has insanely low resource use. It only requires 2 turbine condensers. It literally only requires a single plasma bore for graphite and 3 cliff crushers for sand. Now, power is a whole nother thing. It uses a lot of power, but outside of that, this is very, very light on the resources. One of the prerequisites, obviously, is having carbide, though. Now, I just wanted to make this video just to show the iterative design process of making a schematic, finding a concept that works, and then shrinking it down, running into problems, and then overcoming those problems. It's really simple engineering. That's how engineering works. And yeah, I just wanted to show this video. I plan on making a video in the future going into much more depth about schematic design, about having a goal in mind before you start designing a schematic. But that's going to come later. I'm not ready for that one yet. But yeah, thank you guys for watching. I hope you guys are having a great day.